Now, we need to find V1. V1 of S is the max of these two functions, S minus 5 and the one we just calculated, E of V naught S plus X. And how can we find V1 of S? That's the main topic. We actually want to graph it. So we're going to graph both functions, S minus 5, or say Y is equal to S minus 5, and Y is equal to E V naught S plus X. Okay, so we're going to graph these two functions. How do we do that? We do the piecewise one first. Okay. So let's try to look at where is 5 minus 1/3. So we have, let's say this is 5, and this is 5 minus 1/3. This is S, and this one over here is 5 plus 2/3. Okay. Now let's use a different function for S minus 5. So this is over here. This one over here is S minus 5. In fact, let's go back a little bit. Yeah, S minus 5 is this function. Okay. Now, what about the other function? We need to graph V naught. And we have 3 segments. It says if S is less than 5 minus 1/3, here is 0. Okay. And what we need to do is just find the points at these special values over here. We have this value at 5, and 5 minus 1/3 is 0. Let's look at what's going to be the value at 5 plus 2/3. Okay. This is what we have. If we look at this function, look at the function in the middle or the last one, we look at S is equal to 5 plus 2/3. We look at this value, 1/2 of 1/3 plus S minus 5 squared would be exactly equal to 1/2. This is S minus 5 is 2/3, so this is 1 squared. It's exactly 1/2. Now, this distance over here is going to be 2/3, because we can easily plug in the value. If S is 5 plus 2/3, this is 2/3. So what we have over here, we have a point over here. This is 1/2. Okay. And beyond the 1/2, we have a linear function. So we have a linear function with exactly the same slope. Okay. This one over here is negative 1/6 plus S minus 5. And in the middle, we have a quadratic formula. And we know it has to be continuous. In fact, this one over here is differentiable. So we have something like this. And this segment is the middle one. That's 1/2, 1/3 plus S minus 5 squared. We don't really need a parenthesis over there. Now, if we look at this graph over here, we know what's going to be V1 of S. So V1 of S, I'm going to use a different color. It's a graph we will try to see. We take the maximum. So we take it's the max of this blue line and the red line and the red line over here. Okay. So whoever is bigger, then we have the value. So we have to find now this point over here. This is intersecting point. This is the threshold S1 star. And we have V1 of S is equal to the expected value of V0 S plus X, this function over here, if S is less than or equal to S1 star. Okay, that's the one. And it's going to be equal to S minus 5 if S is bigger than S minus 1 star. Now we just need to find that. And how to find S1 star? S1 star, it's the intersection of these two lines. So what we have, we just set these two things to be equal. 1/2, 1/3 plus S minus 5 squared is equal to the other line, which is exactly S minus 5. Okay? So that's what we have. And based on our experience, we can call S minus 5. Let's say we're going to call this one over here to be another variable. Let's say call it t. So we are solving this one. 1/2, 1/3 plus t squared is equal to t. And that shouldn't be too bad to solve. And then we have 1/3 plus t squared is equal to 2t, right? And then we will have over here 1/3 and plus 1/3 squared plus 2/3 t and plus t squared, and it's equal to 2t. So we have t squared minus 2/3 minus 2, we have 4/3 t, and plus 1/9, and that's equal to 0. Okay. And then we can find t over here using the formula. So we have 4/3 plus minus square root, we have b squared is 16/9 and minus 4/9 and divided by 2. So we have 4/3 plus minus square root 12/9 and over 2. And that actually can be further simplified. It's 4/3 plus minus 1/3 and root 12, and then divided by 2. So it's going to be, we can actually simplify further. This is going to be 2/3 because divided by 2. And this one over here is plus minus 1/3. Remember, root 12 is going to be 2√3. So we cancel 2, and then we have root 3 over here. So this is the one we have. Or we can say t12 is equal to 1/3 and 2 minus or plus root 3. Okay? That would be our candidate for S1. But you remember, this is t, so we have S minus 5 is possibly 1/3 and 2 plus minus root 3. If we go back over there, we know that S1 over here is just a little bit bigger than 5 and smaller than 2/3, right? So the plus sign is not reasonable. So this one over here, S minus 5 is equal to 1/3 2 plus root 3. This one must be discarded because it's way too big. And the one we really have is S minus 5 is equal to 1/3 and 2 minus root 3. This one over here is positive and it's not too large. And then we have S1 star is equal to 5 plus 1/3 and 2 minus root 3. It's a pretty long process, but on the other hand, we are pretty clear about how to find S1. And then after we put this one inside, then we have the value of V1 of S. V1 of S is equal to, it's pretty long to write down the entire expression, so we can just use the expected value. Use the expected value of V naught S plus X. If S is less than or equal to this one, 5 plus 1/3, 2 minus 3, okay? And that's going to be equal to S minus 5 if S is bigger than 5 plus 1/3, 2 minus root 3. And that finishes our computation of V1